To the last section of Competency 10 quiz. In this video, we're still continuing limits, derivatives, and antiderivatives. For the XYZ company, the cost to manufacture X number of tables each day is given by C equals X to the third minus 39X squared plus 480X plus 50. How many tables should this company manufacture each day in order to minimize the cost? Okay, what I prefer doing is getting the value of C prime, entering that in the calculator for the first column, and then putting in our actual cost function in the Y2 column. Okay, so then what we need is C prime equals 3x minus, well, we have 2 times 9, okay, which is 78. If you don't trust that, put it in the calculator real quick. And that's 78x plus 480x plus, oh, there is no plus 50. We're taking the first derivative, and that x goes away. Ah, that looks better. I just started copying everything down. That's not the first derivative. Okay, so let's put these in the calculator. All right, y equals, I am getting rid of these so I can see it. Okay, so what do we have here? And let's make y2 no, let's leave it orange so we can see it better because we're really going to be looking at the columns. That's what I'm trying to say. Okay, so in the y1, we need the first derivative. And you'll see it's just a little easier to do it. That's why I have this habit. Okay, and then this will be in the Y2 column. All right. Okay. Let's arrow over and we have, oh, that's 3x squared. I see another mistake I made. Oh my gosh. Okay. 3x squared minus 78x plus 480. Let me double check my chain rule. 3 comes down, you have an x, a square, minus 2 times 39, that is correct. Then x, and then just the plus 480. Okay, that is correct. Had to double check that. Okay, now let's just put in what we have, the given for the cost function. So x carried up to the third, we have to arrow over, and that is minus 39 x squared, okay, and then plus 480 x, and then plus 50. All right, let's graph that. Shouldn't be very, yeah, see, it's like off. See what's going on? You have it on the edge. I mean, we can move that over and get a glimpse. Honest truth is that's not what we're using. We are not using the graph. This is what we're doing. Go second, graph to get to the table. Now we have something to work with. Okay, and we're using numbers that are too large. So, you know what? Let's go ahead. Let's look at the graph. Maybe if we see that pink on the edge, maybe we can get a minimum and the roots of that and then make some judgments. Technically, we don't need it. We could scroll up and down, but I'm not going to do that. First thing, change the window. I'm not going to change the minimum and maximum of the Y. I just want to scoot to the right and capture that all of the X. So we want maybe -1. Let me do it for you. Okay, let's go window. Do not touch the Y values. That's fine. So I'm thinking I want -1 there to scoot it over. And then the maximum, let's try 20 for the X, okay? I'm going to push enter, and now I'm going to graph it. Okay, that's much better. Now over here near the x-axis, I mean not x-axis, y-axis near the origin, we see part of the original. What we have in the pink is the derivative, if you remember. Okay, and it looks like we have whole numbers we're dealing with or close to it. And 1, 2, 3, 4, 5, 6, 7, 8, 9, or somewhere around 10. Okay, now what we do is go second window. Okay, I want to start at 10 and let's try whole numbers, so increments of 1. So that's table range, okay? So let's go back to the table by doing second graph. Ah, there we go. See, I wanted those 0 values, okay? Let's look at the zeros. And at those values of 0, remember your pink will be the first derivative, okay? That's what we want, the C prime. Now, let's look at where it says x is 10, the derivative is 0, but 1,950, okay? That's one cost we're looking at. Now let's compare it to the other 0 value. Okay, we have 16 is our x. That's the other 0, our root, but it's 1,842, which is less. So this means our minimum cost is achieved at x number at 16. 16 tables per day gives us a minimum cost. 10 would have cost more, and sometimes that happens. Sometimes you get your best value if you manufacture a few more because some of the other cost you're already paying out. And manufacturing other things for sale will kind of absorb that cost as you sell them. Anyway, that's the hope. I don't know if that always occurs. Okay, so let's go to number 17. Okay, and I'm trying to move this best I can there it is. Okay, the area inside a circle is being expanded at a rate of 10 square inches per minute. Okay, one thing we need to note is this is a rate. Okay, all right, it's not a position. All right, at what rate is the radius changing? Is changing at the instant that the radius is 3 inches. Okay, so what we really need is this formula, okay, to get the area. Okay, this is what we're really saying. We're saying that the rate, the rate of the area at time t is equal to the rate of the area, the rate of change of the area with respect to the radius times the rate of change of the radius with respect to time. Okay, that's a lot to wrap your head around if you haven't done these. If you're not super familiar with this, I recommend that there's lots of great websites. Google it, maybe books. Go in a little more depth and go and reach out. Now, I do have my favorite YouTube channel of someone. I haven't looked this up in that particular channel, but you could try, okay? But these are everywhere. All kinds of great problems, practice problems. Okay. All right. So, this being said, let's see what we have here. We can literally fill in the blanks, okay? The first thing that we need to do is get this radius with respect to r. We already have the rate of change with respect to time. That's here. It says, well, they're cluing us in 10 square inches per minute. That is the area changing at per minute. That's with respect to time. So that'll be 10. Okay, now we need to come over here and deal with, we just need the first derivative of area of the circle. Well, area is pi r squared. So A prime would equal 2r pi. So that means, oh, but not just that, at the 3 inches. So now we need A prime 3. That is the first derivative at 3 inches. Okay, and then, oh, well, we'll write them in order. I was going to write them out of order. So that is 2 times the 3 times pi, and that will be 6 pi. Okay, so, oops. Ooh, it's real sensitive today. So that is 6 pi. But what we don't have a value for is the change of r. Isn't that what we're looking for? Yes. So our variable is the change of r, which just so happens to be the r prime. Okay. So I'm going to drop the t and just call it r prime, which often when you're in class, you've seen professors do that. I know what they're doing, but I wish that they wouldn't combine it. But anyway, sometimes they drop it without telling you. That's what I really don't want. So we have to divide both sides by 6 pi. All right, so that gives us our rate of the radius, but we have to simplify that. Well, divide the numerator and denominator by 2. That gives us 5 over 3 pi, which is option C. Makes sense. Okay, now let's go to 18. Okay, 18 is, okay, they give us the integral 12 over x minus tangent x dx. Okay, which is equivalent to which function? I know the way they word that is funny, but we'll go with it. So they're saying, what is the equivalent function to this integral? Which would make more sense to me. Doesn't matter. Well, the first thing that we see is that we need to integrate each term by term separately. Okay? All right. So this means that the 12 will be hanging on all out there by itself. We just write him down and come back to him. Then what we have is really 1 over x. So 1 over x is natural logarithm of the x. So those are technically multiplied together. Okay, so we've integrated that. Now we have what? Tangent. Okay, well, we have a subtraction, but then the tangent on its own, that becomes negative natural log of cosine x. Okay. Oh, I'm sorry. Negative natural log of cosine x. So this becomes negative natural log of cosine x. Okay, and then don't forget your plus c. Okay, so then this means here we should have a plus. Okay, well, I see some things that are already incorrect. Okay, I see that, oh, you know what? Let me change this because I'm covering up some of our problem. Right, just in case someone's trying to go through the video and doesn't see that natural log. Okay. All right. So looks like we got a couple things going on here. I do not agree with B and C. If they are integrated incorrectly in more than one way, they're done. Okay, for A and D, I disagree. I mean, I agree with the first terms. Those have been integrated correctly. Now, looking at the second term, I like the integration, but I do not like the fact that they forgot the negative in parentheses the negative that really is part of the integration. So I'm not sure what that's about. So that means, and I purposely circled this and pointed out the positive because this will give us D and A would be incorrect. Okay. All right, let's go to the next one. Number 19. Number 19, what is the value of this integral? Okay, the integral goes from 1 to 4. So let's put this in the calculator and we can get a value very, very quickly. I really like these kind of questions, okay? All right, so we have alpha window and we will go to number 4. Okay, now we put in 1, arrow up, put in number 4, arrow to the right. Okay, 2x squared plus 5 and x and enter 57, and that is the correct value. It'd be great if something like this was on test. I have yet to get anything this fabulous. But if they ask you a question where you're adding integrals up in some way or subtracting the values, that would be something more that would happen, something more involved, then at least you know how to get the bits and pieces. And talking about bits and pieces, that is how we're going to handle 20. Okay. Let's see if we can scoot up enough. Okay. So the diagram describes the function. So we have a graph and it describes this function. So let's put the function in first. We need that in the calculator. So we need y1. And I'm going to just go ahead and clear these out. Okay. All right, so let's put in negative x squared, yes, plus 9. I don't want to let's go back up to 1. Not that it matters, but I wanted that brighter color. It looks better on the video. It shows up better. So negative x squared, then plus the 9. Okay, let's graph it. Ooh, we need to move our graph back over. Okay, we moved it one way. Now we got to move back. Not a big deal. Okay, so just push window and let's go negative 1, 0, and then go back to 10 on. Remember, we only changed our x coordinate, our x axis length. So we don't want to mess with anything else. So the y is fine. So let's graph it. Ah, there we go. Wonderful. Okay, so what are we really doing here? We need to use these values here and here and here. And let's just go piece by piece, okay? So I know that there was other ways where I showed the integration by using the alpha window and we got one, then we added another. Uh, Let's not do that. Let's do it just using the graph, okay? So let's say second trace, which is the calc. We're looking for the blue calc. Then we need integration, so we go to 7 and see what the lower limit. So we need the lower limit, put it in. That is negative 3 minus 3. You just type it right in and you see what you type and then you push enter. Now it asks for the upper. Do not go all the way to this 5. Go to 3. Okay, so let's push 3, enter. It is totally shaded, telling us that's the area that you're telling me, and go to the integration line above the interval. They give you the interval you chose. So pick you pick out that derivative above it, which is 36. Hey, yeah, you really have to look at your calculator. Honestly, on this screen, it is a little smaller, but that's fine. When you use your own calculator, of course, you can look at it, see it very clearly. Okay, now we need to do the other section. You may say, "Oh, well, you need to squeeze in or go down on your window." No, we don't. It will just give it to us, okay? The the position of the window will not affect what we enter. It will give us what we enter, okay? All right. So let's do that. So go second, trace again, and number 7, and simply enter 3 first and then the 5, okay? 3, enter. Okay, 5, enter. And in the same place, it gives us a value. However, that value is negative. Remember, its area, we are simply taking the absolute value. When we were doing it numerically, that is what we did. Pictorially, still the same. So the absolute value of a negative is the positive. So we just need that 14 with 6 repeating. Now we add the values of the two areas together. So second mode, all right, let's say 36 plus 14 point. Okay, for that 6 repeating, I'm just going to enter enough, and it actually works. Just enter enough of them. See what I did? Okay, and then I push enter, and then I go math, and it's on fraction. Push again. And you're like, well, that's not the fraction we have down here in our answer options. Doesn't matter. We need to go alpha, window, arrow over, and we're going to number 3 to switch our our fraction to a mixed number. Okay, push enter. Oh no, shoot, let me clear it, go and grab it. Let me grab it again, push enter. Okay, now it's set up, alpha, window. Yeah, I must have pushed something. There it is. All right, I didn't mean okay, there it is. Sometimes if you push something, you have to go up and grab it again and do what I did to refresh it, and then you get your answer. I pushed something too many times. I thought I pushed 3 and I hit 2. Who knows? So, option B is the correct answer. Okay, this is the last video. That was number 20. Yes, last question and last video for the Competency 10 quiz. Okay, next we'll go on. I know that we're going backwards. We will go to Competency 9 very quickly. Okay, and again, thank you for sharing and liking a lot of the videos and subscribing. And happy testing.